A very good morning to all of you. I, Preeti Patel, on behalf of ISF College of Pharmacy Moga, welcome you all in the dialogue series under the aegis of IQAC, IIC, ISFCP. Dr. Hemant Jain is the expert for the day. I welcome you, sir.
Thank you, madam.
Dr. Hemant Kumar Jain is currently working as professor at SEFS Suryadatta College of Pharmacy, Healthcare and Research, Pune. He has completed his bachelor, PG and PhD from Dr. Hari Singh Kaur Center, University, Sagar, and he has rich academic experience and delivered more than 45 lectures as a resource person at different places. And sir has also prepared many educational resources video for the benefit of students. So before starting the program, I request to our director, sir, please say a few words.
So thank you very much, Dr. Preeti ji. So first, welcome today's expert, very dynamic and very laborious and down to our person, Dr. Hemant Jain ji, with us. So I welcome you. Today's all these persons, who are the connect with the YouTube channel as well as online. So as and it is not very easy job to each and every person, including the experts and the coordinators. So this is the strength of the this ISF dialogue series. Everybody from the, you can say, institute as well as from the experts, they are taking the pain in the benefit of the profession, in the benefit of the society. For the he is given his the precious time for the discussion and deliver a talk under the ISF dialogue series. So I am thankful from my heart. They and
Thank you.
interacting with the some of the dynamic person. So without taking time, I again welcome today's expert, Dr. Hemant Jain, and I also welcome all the participants who are connect with the YouTube channel. Thank you very much, Dr. Hemanji. Now I request Dr. T, please proceed.
Thank you, sir.
Thank you, sir, for nice words. So, our expert going to deliver lecture on fundamental of IR spectroscopy for pharmaceutical analysis. So, I request to Dr. Hemant Jain, sir. Please proceed, sir.
Thank you, madam.
Thank you, sir.
Just I want to share the screen.
Yes, sir, definitely.
Namaste. The
Namaskar.
topic is the fundamentals of the infrared spectroscopy for the pharmaceutical analysis. And there is one disclaimer that the participants should have the basic knowledge of the analysis and should know the principles of the chemistry. This is the beginner guide. Time duration is very short, so I have tried to compile it in a short time. I have taken some animation, photos, videos from the unnamed sources. Today's content is the principal molecular vibrations, IR spectrophotometer, FTIR, sampling techniques, and factor affecting. So, first, what is the electromagnetic spectrum? The word is the electro means electric field. Magnetic means magnetic field. So there are two vectors, electric vector and magnetic vectors. If we consider in terms of the equation E equal to h nu or hc upon lambda. So h is the Planck constant, c is the velocity of the light, lambda is the wavelength. If we consider in terms of the IR, it is the Hc nu bar. Nu bar is the wave number. If we consider the whole spectrum, we can see the visual light by the naked eye. But if the wavelength of the visual light is less than the violet wavelength is 390 nanometer, it is called ultraviolet. Ultra means less. So less than violet is called ultraviolet, and more than red, if the wavelength is more than red, that is called infrared. And we are dealing today with the IR. So IR spectrum is having the wavelength more than red wavelength. Red wavelength is the 780 nanometer. So IR spectroscopy study the interaction between the molecule and IR radiation. If we consider the IR region, there are three categories of the IR region: near IR, mid IR, and far IR. So generally for the pharmaceutical analysis, we are using the wavelength or wave number. Wavelength is the 2.5 to 50 micron, and wave number is the 4000 centimeter inverse to 200 centimeter inverse. So for pharmaceutical analysis, this wavelength is appropriate. Now there is some reflection point. I am asking few questions. Have you experienced the IR radiation in your life? Have you observed the utility of the IR during the corona period? What type of the molecular vibrations requires more energy? How ATR work? Which factor affect vibrational frequency? So we should think. If we consider the IR radiation, if we see just this is the whole spectrum. Visible spectrum we can see by the naked eye. But if the wavelength is more than red, that is called infrared. More than red is called infrared. So there is infrared light along with the sunlight. If we focus this particular infrared light on a thermometer, the temperature is more. You can record the temperature, but the temperature is more. But if you keep the sample in between this, then temperature is less. So I am showing this. Without sample, temperature is more, and after placing sample, temperature is less. That means some amount of the or some intensity of the radiation is absorbed by the sample. So initially there is no sample, and after that there is sample. So there is a temperature difference. Okay, so we can say that IR radiations are related something to the temperature. We can say that in layman language. Now I am showing how the utility of the IR is there in the COVID period, corona period, we can say that. So how IR sensors work? And when the person is having the temperature more than 37, then the signal is red. And when the temperature is less than 37, it is green. Okay, so due to that temperature monitoring is there. And I want to just cover up something that what happened during the COVID period and how IR sensors work. What happened during the COVID? This is the virus, and this virus multiply drastically. And what happened when it multiply drastically? There is the inflammation, and due to the inflammation there is increase in the body temperature, and IR sensors detect. So that was the utility during the COVID period. Now I am discussing the basic principle. So IR radiations are there. When these radiations passes through the sample, the transmitted IR radiation, the intensity of the transmitted IR radiation is less. And initially, if the sample is not IR active, then we can say that same intensity. If the sample is IR active, then less amount of the IR radiation transmitted, and that can be recorded by the IR sensor. Now I am discussing the frequency. So these frequencies are related to the wave number. Okay, and wave number is the inverse of the wavelength. So if we see the upper, we can say that spectrum, wavelength is more and frequency is less, while in lower spectrum wavelength is less, wave number is more, frequency is more. Now question is that which frequency or which wave number is suitable for the IR radiation? So the answer is simple. The vibration, the wavelength which is suitable, that cause the vibration or rotation within the molecule. So there is net change in the dipole moment. If there is a net change in the dipole moment, there is IR absorption. So when the radiation frequency matches the vibrational frequency of the molecule, IR absorption is there. If we consider this is the simple molecule, and when the IR radiation pass, so vibration get increased. Initially there are less, we can say that vibrations are less, but after the IR radiations there is more vibration. Now which type of the vibrations are there? So there are two categories of the vibration. One is the stretching vibration. Stretching, if you see this particular bond, there is some stretching and compression, stretching, compression, like that. So we can make it like a spring model. If we consider the type of the stretching, there is a symmetrical stretching. In symmetrical stretching, the bond are, we can say that, compressed together and stretched together. While in asymmetrical stretching, one bond stretch and another compress. So this is the way. Now we can see this particular animation I have taken from the, we can say that, unnamed sources. This is the, we can say that, video of the cricket match. So what happened when sixer is there? There is a cheer girl, and that just cheer. So there is a rocking, there is a scissoring. So I have observed during the cricket match such type of the, we can say that, arrangements are there, and similarly bending vibrations are there. So these vibrations are categorized in plane vibration and out plane vibration. In plane vibration is the rocking, scissoring. Okay, this is the scissoring, we can say that. Then twisting. Twisting is the out of plane, and wagging. So these are the bending vibration. If you consider that which vibration require more energy, whether the stretching vibration or bending vibration. So stretching require more energy and bending require less energy. This is the very famous law, Hooke's law, and that correlate the frequency. Here general term is the frequency, but exact term is the wave number. So wave number is related to the force constant. Okay, and it is also related with the reduced mass. So if we consider by the two ball A and ball B, what is the reduced mass? If ball A is having the MA mass and ball B is having the MB mass, so reduced mass is the MA/MB upon MA plus MB. So this is the, we can say that, formula, and here wave number is directly proportional to the under root of the K. K is the constant. So if the value of K is more, wave number is more. If we consider, so if we consider the types of the molecule, this is the saturated molecule. Okay, C, single bond C. So the value of the, we can say that, wave number is the 1200 centimeter inverse. While more, when the more unsaturation is there, the value of K is increased. And in case of triple bond is we can say that most powerful. Double bond is powerful than the single bond. Okay, so this power is increasing in the left hand side. When the power increasing left hand side, the value of K increase and wave number increase. Okay, similarly, reduced mass also play the important role. If we consider the mass of hydrogen, mass of hydrogen is less, while carbon, oxygen, chlorine, bromine, that is more. Okay, so at right hand side, reduced mass is more. So frequency is less. When we increase the reduced mass, the frequency reduce. Okay, so in this way, lighter atom having the higher frequency and stronger bond is having the higher frequency. Now I am coming to the instrumentation. This is the infrared source. Then this is the focusing mirror. By the mirror, radiation come. These radiations passes through the sample. Sample absorbs some amount of the radiations, and that reduction of the intensity of the radiation is detected by the detector. So this is the simplified IR spectrophotometer. Now, how the data is plotted? So data is plotted in terms of spectrum. IR spectrum, along y-axis there is transmittance, along x-axis there is frequency. Exact term is the wave number, but commonly we use the term frequency in centimeter inverse. Okay, so this is the spectrum. So dips are there, and these dips are called peaks. So these are the IR peak. So we can say that these are the absorption peak or IR peak. If we consider the sources, so there are different types of the sources: Nast glower, wire, mercury arc, like that. If you consider the detection system, there are detector. And most of the detectors are based on the difference in the temperature. Thermal, piezoelectric, photoconducting. So these are the detector. Now I am going to discuss the FTIR, Fourier transformation infrared spectrometer. So if we see that there is a system, and this system consists of radiation source. Okay, this is the radiation source, and there are two mirror. This mirror is the moving mirror, while this mirror is the static mirror. Okay, and there is a detector, photo detector. If we place the sample here, then what happened? So initially monochromatic light come, and this monochromatic light strike with the moving mirror. So this light is divided into two parts, and when this light is strike with the mirror, it again come, and here these two beam of the light interact and passes through the sample, and then it reaches to the detector. So if you consider here, the direction of the light is there, and this light is exactly overlapping. Okay, if we see this here, there is a interference. Okay, and that interference is recorded. So just I am showing, if we see that this is the monochromatic light, and this monochromatic light is strike with the mirror. Okay, so exactly it come back, and here also some part of the light, half of the light come here and half of the light come here. So these lights come together and these lights join together. Okay, so there is a constructive interference, we can say that. Okay, and the value is more. Okay, so this is the overlapping, and this is called constructive interference. So if the distance of the mirror is equal, there is a constructive interference. But when we move it, just I am trying to move it. When we change the distance, so this mirror is just move. So what happened? Just we see that. So when this is the moving mirror. So when we move this particular mirror in the left hand side, what happened? So one beam is like this, while another beam is just like opposite. So what happened? So these two beams are counteracting each other, cancelling out each other. And this is called destructive interference. So initially constructive, then destructive interference. Okay, so in this way, FTIR work. When we move the mirror position again, there is a constructive, then destructive. So in this way, this is called interferogram. And this interferogram is converted into the spectrum. So in this way, Fourier transformation spectrometer work. Now I am going to discuss the sampling technique. So this is the we can say that sample holder, and this sample holder is suitable for the gas and liquid. And when the IR radiation passes through it, if the sample is IR active, then it absorbs some intensity of the radiation. So solid and gas are handled by this, and in this way the sampling is there for the solid and gas. While we can say that just sorry to say, I am showing the earlier. Okay, so here liquid and gas are kept inside this particular sample holder, and the intensity of the liquid and gas is monitored by that particular type of sample holder. While solid is mixed with the KBr, potassium bromide, and pellets, usually pellets are formed, and these pellets are the semi-transparent pellet, and when the IR beam passes through it, some amount of the IR radiation get absorbed, and intensity of the IR light is less. And next I am telling the ATR. So ATR technique, just a minute. In ATR technique, there is a ATR crystal. So this is the ATR crystal, and this crystal is having a particular surface. Okay, so here on this particular surface, the sample is kept. Now I am showing the animation. So here the IR beam come, and when this IR beam enter for few micron inside the sample, and then it is totally reflected. It does not pass through the sample, but it is totally reflected. When the critical angle is more, when the angle is more than the critical angle, there is a total internal reflection. This is the physics law, and same law is applicable here. So here in this particular technique, total internal reflection is there, and the beam is reflected. And in this way, this particular technique work. This is the attenuated total reflectance. Then if we use this particular technique, when in one reflection the intensity is less, so in that case we use the multi-reflection ATR crystal. So here the reflection is multiple times. When the reflection is multiple times, the intensity is increased, and we can say that sensitivity get increased. So we can see that how this particular sample is having the, we can say that, less sensitivity, while if we use the multiple ATR technique, this intensity is more or sensitivity is more. Now I am telling the press pellet technique. So KBR is mixed, sample is mixed with the KBR, and by the press, these KBR pellets made, and the IR light passes through the KBR pellet. So in this way, the sampling is there. Sometimes liquid is spread as a thin film, and gas is also kept in the cylindrical cell. Okay. Now I'm coming to the advantage. This is the fast technique. We can perform the analysis within the seconds. Sensitive technique, mechanical simple, and internally calibrated. Now I'm coming to the interpretation of the IR. So here the graph is there, and along the y-axis there is a percent transmittance, and along the x-axis there is the wave number. If we consider these dips are called peak, or these are called band. When 100% transmittance is there is no absorption, and when 0% transmittance is there, we can say that all radiation is absorbed. Now I am coming to the regions of the IR spectrum. One is the fingerprint region. Fingerprint region is the 1400 to 400 centimeter inverse. And another is the functional group region, that is the 4000 to 1400 inverse. Fingerprint region tells the characteristic property of the molecule. Okay. So if the big molecule, suppose that this is the big molecule, more than 6 carbon, more than 8 carbon. So this particular molecule is having some characteristic property. Okay. And this, there are certain dips observed in this region, 1400 to 400. Okay. And another region is the functional group region. So that gives the idea about the which type of the functional group is there. Suppose that this is the 2971. So that tells about the stretching band. Now, if we interpret in a simple way, there are certain regions. So here we can see that single bond is there, CH, NH, OH in this region, 2500 to 4000. When unsaturation is there, it is nearby 2000 to 2500, and so on. So if we see that single bond C, single bond H, if we consider the base value, so below 3000, the hybridization is the sp3 hybridization, and this sp3 hybridization is there in the saturated compound. Okay, so when the CH is there and there this particular carbon is not having any unsaturation, in that case the value of the IR radiation is less than 3000. But when the carbon is unsaturated carbon, in that case the value of the IR peak is more than 3000. So in case of sp2 hybridization and sp hybridization, the value is more than 3000. Similarly, with the aldehyde group, they are having the two peak, 2900 plus minus 50. So if we see 3000 is the base value, below 3000 there is a sp3 hybridization, we can say that the saturated compound, and after 3000 we can see that unsaturated compounds. So if we see the methylene group is the CH2 group, and methylene group is having the such type of the vibration, symmetrical stretching, asymmetrical stretching, the value is the 2926. Then if we see that in phase and out phase, so the value is the 2872 near about, and asymmetrical stretching is having the 2962. So I'm just trying to explain the simple example, hexane, normal hexane. So normal hexane is the straight chain molecule, we can say that. And in the normal hexane, there are certain peaks. And these peaks represents to the stretching vibration. Why the value of these peaks coming at the left hand side, or why these values are more? Because stretching bands are more powerful. Therefore, the value is coming here around 3000. But this particular compound is the saturated compound, so values are the less than 3000. These values near to the 3000 but less than 3000. Then what is about these? So these are the related to the bending region, and bending require the less energy. If I am taking the paper, this is the paper. So if I stretch it, I require more energy, and if I bend it, it require less energy. Bending require less energy, so value of K is less. When the value of K is less, the value of the wave number or value of the frequency is less. So bending require the less energy, so value of this bending vibration is near 1500 or less than 1500. So methylene group is having the such type: inpilin scissoring, inpilin rocking, the value is the 720. Wagging is the out of plane, so the value is the 1250. And twisting is there, that is out of plane, so that is 1250. So in this way, the methylene group, methyl group are there. Methyl group is having the bending vibration 1465. Sorry, methylene group is having the 1465, and methyl group is having the two types of the bending. One is the asymmetric, that is the 1460, and symmetric 1375. Okay, so that depends on the adjacent. If the two, we can say that methyl groups are there together, we can say that isopropyl group, in that case it's the 380, 1380, 1370. And if it is the tertiary butyl, the values are 1390 and 1370, like that. So in case of alkene, I have given the example of the normal hexane. These are the stretching values near 3000, and these are the bending vibration less than 1500. This is less than 3000. And this peak is tells the characteristics of the molecule. So this comes under in the fingerprint region, because this chain is more than 4 carbon chain. Similarly, if the unsaturation is there, so here unsaturation is there, double bond is there. When double bond is there, this particular functional group or this particular bond is represented by one more peak. So the peak found at the 3082. So the value is more than 3000. Similarly, in case of toluene, so if you see here, so in this particular case, the value is the if we see here, this particular value is more than 3000, and CH3 group value is having the 2900. Okay, so and similarly the bending vibration is also there, so it appears at around 1500. Okay, if you see here, this is the out of plane. Oops. So aromatic group is having the characteristic property. This comes in under the fingerprint region. So in this way, we can find out the or we can interpret the values, IR values, and we can interpret with the functional group. If it is the highly unsaturated compound, triple bond is there, C triple bond C, the value is around 3300. This particular value appears here, and similar values are and remaining values are similar as compared to normal hexane. This is the hexane. Okay, so in this way the values come. Okay, so thank you to the management, director, moderator, team of ISFCP, and all the learners. Thank you. Dhanyavad. Namaste.
Thank you so much, sir. It was very wonderful lecture about the IR spectroscopy, and you gave very meaningful insights about the IR spectroscopy, its basic principle, and especially about the IR sensors, the use of IR sensors during the COVID. And most important thing about the lecture, you have included the interpretation of various compounds, yeah, or basic knowledge about the absorption peaks in the IR region. So, sir, we are grateful for your time and efforts you took to share your knowledge and experience with this ISFCP dialogue series, and I believe we will further connect in future. So on the behalf of whole ISFCP family, I am thanking you, sir. And
thank you, madam. Thank you.
thanking you, sir. Now, sir, you may leave.